All right, so we are reviewing Physics 1 for Physics 2. Another concept that we are going to use in Physics 2 is F equals ma, otherwise known as Newton's second law. Written out, Newton's second law can be said when the net force acting on an object is not zero, the object will accelerate, meaning it will speed up, slow down, or change directions. The direction of the acceleration is the same as the direction of the net force, and the amount of the acceleration depends on the object's mass and the strength of the net force. And that can be just written as the equation F net is equal to ma. So this problem shows up anytime we've got forces acting on an object and we want to know the acceleration, or we know the acceleration on an object and we want to know how strong the forces are that are acting on it. So let's say that a lacrosse ball is falling through the air at 24.8 meters per second, which, by the way, is pretty fast. That's over 50 miles an hour. Okay, and speeding up at 9.31 meters per second squared. The ball's mass is 0.185 kilograms. Now, normally I would look up the actual mass of a lacrosse ball to give a problem because I like to make my problems realistic, but here I just made that up, so it is not the actual mass of a lacrosse ball. So maybe this is just a ball is falling through the air at 24.8 meters per second and speeding up at 9.31 meters per second squared, and the ball has a mass of 0.185 kilograms. So what I want to know is how strong are the gravitational and air resistance forces acting on the ball. Okay, so there are a couple of things going on here. So we got two forces acting on the ball. Gravity is pulling on the ball, and air resistance is pushing on the ball, and the ball's falling through the air. Okay, we are going to solve this using Newton's second law. So we are going to use F net is equal to ma. And if you haven't had me for Physics 1, this is going to look just slightly different than what you might be used to. A lot of physics professors will talk about a free body diagram. I talk about a picture equation, which is like a free body diagram, except it has both parts of this equation. So what I'm going to do is I'm going to draw a circle to represent my ball, and this equal sign represents the Newton's second law equation, F equals ma. So on the left-hand side of the equal sign, we're going to put all the forces. And on the right-hand side of the equal sign is where we're going to put the mass and the acceleration. So we are, and on our picture equation, we're not going to use any numbers. We're only going to use symbols to describe the different quantities. So for mass, we're going to use m, and then for acceleration, we're going to use a, and we want an arrow representing the direction of the acceleration. Now this ball's falling through the air and speeding up. So because it's falling, I know that it's moving downward. And because it's speeding up, I know that the acceleration points in the same direction that it's moving. So that means the acceleration points down. Okay, so that is the right-hand side of the equation. On the left-hand side of the equation, I want all the forces acting on the ball. So we know that gravity is acting on the ball, and we know that gravity always pulls everything down. So we're going to label this force of gravity. We also know that there's an air resistance force acting on the ball, and air resistance is going to be pushing up on the ball. We know that because the ball is falling. And if you're falling through the air is going to push up on you. And so that I'm going to label F sub A for air, or air resistance. Okay, and then the last thing I'm going to do is decide which direction I want to make positive. And I'm going to make the downward direction positive, and I'm doing that because the acceleration points down, and I like to make the downward direction the same as the acceleration. Okay, so now I take this picture equation and I convert it into a math equation, and this math equation is supposed to look like, if we add up all the forces on the object, it's equal to the mass times acceleration of the object. And anything that points down should be positive, and anything that points up should be negative. So when I'm looking at my forces, force of gravity is down, so that can be positive. So I've got force of gravity. The force of air is up, so that can be negative, minus the force of air is equal to, and the acceleration is down, so my ma is going to be positive because it points down. If the ma had pointed up, I would put a negative sign in front of it because it was in the negative direction. But my ma points down, which is the positive direction, so it's just ma. All right, so this is my Newton's law equation. This is my F equals ma. And from that, we could try to find the air resistance force. The problem asks me to find both the air resistance force and the gravitational force. The gravitational force, we need to remember from Physics 1, is equal to mg. So the gravitational force is equal to the mass of the ball, 0.185, times g, 9.81. So the gravitational force is 1.81485 newtons. Now, of course, I need significant digits, but I'm not going to do that yet because I'm not finished with the problem. Looking at my boxed equation and doing some algebra, if I add Fa to both sides, I get the force of gravity is equal to Fa plus ma. And now if I subtract ma from both sides, I get the force of gravity minus ma is equal to Fa, which is good because that's what I'm looking for. So now I can plug in my numbers. I already have a number for force of gravity, so I'm going to take that number and I'm going to subtract from it the mass times the acceleration. So my mass is 0.185 and my acceleration is 9.31. So I'm left with my force of air resistance is equal to 0.0925 newtons. And if we use significant figures, this problem has 3 significant figures. So I'm going to round each of these to 3 significant figures. Force of gravity is 1.81 newtons, and air resistance force is 0.0925 newtons. Now, one thing to notice is that the air resistance force is much less than the gravitational force. That does make sense because this ball is accelerating downward, so gravity should be stronger than air resistance. And the gravitational force is about 2 newtons, which is similar to the weight of 2 apples, and I do think a lacrosse ball probably is about 2 apples worth, so that does make sense. All right, that is all. If you want to know more about Newton's second law, you can go back and look at my videos from Physics 1.